Ulrich, what brings you into Israel?
Wonderful people like you guys. That's what brings me to Israel, and obviously the innovation spirit in the startup nation. So I saw, I don't know how many startups over the last 3 days. Fantastic innovation, fantastic people. So just great to be back out there because I've been like you guys stuck for 18 months or whatever it now is at home, which is very unusual. So super to be back here.
Nice to hear that. Great. Can you tell the audience a little bit about your role in Microsoft?
Yeah, so I have this fantastic, weird role that effectively is in engineering, but I'm not an engineer. I work a lot with customers, but I'm not in sales, right? So part of what I do is driving what we call customer-led innovation. So one of the things that I do is spend time with customers, partners around the globe, help them understand what we do and what we're investing in, and most of the time, why are we doing this? Not necessarily the bits and bytes. We have fantastic people in Israel that can do that, but a lot of times the people here don't know why we make the decision or what are we going to do and why is it going this way rather than that way. And then I listen and spend time with the partners or customers, ideally on a project, where we then try the tech, and then most likely we will find the tech doesn't quite work or isn't quite right. And then I work with the engineering teams to figure out how would we fix it, do we want to do this. In rare cases, I also have the pleasure of innovating and investing, creating a new category that we haven't invested in because from going to customer, I see gaps that are consistent that we just don't meet today. And I then go work with business development, engineering strategy to say, should we invest in this category or not? Connected vehicle is a great example. In 2014, I spent a lot of time with Renault, BMW, and all these guys, and they consistently said there's really no cloud native scale platform connected vehicle. They had connected vehicle solutions, but they were all on-prem or fairly limited in terms of scalability. So we decided to build a connected vehicle platform. And that was one of the things that I was allowed to drive as a new thing instead of just adding capabilities to existing stuff. So if I get lucky, I get to invent new things. If I am not, quote unquote, not lucky, I get to add specific capabilities to stuff.
Okay, great to hear that. You're talking about customers. We at the cloud, we see many customers starting their steps into the cloud. What can you advise new customers as they take their journey and they start their journey into the cloud?
Tongue in cheek, they're late. But obviously, there's a couple of things that I see. One is have a clear perspective. Why are you doing this cloud thing? Not just because it's cloud. It must be awesome. It is awesome, but you should think for yourself what is really important for you. What are you going to do? Is it cost saving? Is it innovation you want to drive? Is it both? So I think having a clear perspective and roadmap, what you want to invest in and why, is important. The second part is, and thank God, we have certainly done the investment, other people as well, is now cloud adoption frameworks out there. Ours is called Cloud Adoption Framework, and there is a lot of guidance and IP in there of how you stand up the cloud environment. So I've seen, unfortunately, a lot of technology-driven folks that try to look at the building blocks that Azure provides, Azure Resource Management and policy and whatnot, and are saying, I know how to build a Ferrari out of this one. And they 9 months later, 12 months later, they still don't have a cloud environment that's secure, safe, and scalable. Instead of going with the, for example, enterprise landing zones, and just start with that and configure or customize from that piece of IP. So have a plan of what workloads you care about, what you want out of the cloud, and then utilize IP that's out there so that you have a safe, scalable landing zone, for example, environment that allows you to manage what the cloud does for you.
Okay. I see many customers use a lot of, they manipulate data. They use data warehouses. There are 4 major technologies when speaking about data warehouses. Snowflake, BigQuery, Databricks, and Synapse. And you talked about innovation. Synapse is new to the market. What benefits Synapse brings to the table that others don't?
Well, Synapse is a product that came out of learning of, let's say, 6-7 years of big data projects, and most of those projects failed because the technology is complicated. If you go into Azure, just looking for the services, most of them you would have to do 10 different services, from Azure Data Factory to the data lake to maybe Databricks for Spark, or you do HD Insight, then you throw a data warehouse at it, and you are the integrator. You have to make that all work. And there's no consistent security, there's no consistent deployment, there's no consistent monitoring. So effectively, it's a really complex set of capabilities. And so we decided 3 years ago that we would go and build a single system that effectively combines big data technologies, and we focused on Spark, and data warehouse technologies, our SQL data warehouse capabilities, and bring them together. Bring them together in 2 dimensions. One, functionally. So if you are a data engineer that wants to build, on the one side, working with big data, but then end up in a warehouse to write a OLAP query or something like that, normally you would have 2 different tool sets. You have to go and teach the SQL data warehouse about the result sets you're getting out of the Spark system and so forth. And we have integrated that. So the Spark engine and the SQL engine actually share metadata between each other. So you can write a single notebook and effectively start with a Spark query and then have a T-SQL query in the same workbook. And the engines make sure that the data sets are known to each other and effectively make it very smooth and easy. So that's one innovation level. The other innovation is all about enterprise capabilities. Single deployment, single tooling, single management, single security across all of these capabilities. So again, underneath the covers, there are still a whole bunch of these services. We just made the integration work automatically. And now this trend of integrating big data with big structured processing, data warehouses, is becoming the norm. So you saw Snowflake announce their Spark capabilities. Databricks is working very heavily on SQL and so forth. So again, we set the trend, and I personally believe we are still leading the pack there, but the competition is always welcome.
Okay, so there's competition, and customers usually think about multi-cloud. They want to be cloud agnostic. Many customers actually struggle when they think about other clouds, and sometimes it's actually necessary. So what's your approach? There's Synapse, there's other features on other clouds. When should we do it? Why?
Well, first of all, let's define what multi-cloud is. So there are 2 things I generally see. One is, hey, I'm going to use Microsoft, Google, Amazon, God knows what, and I'm going to pick the best capabilities for each, and I place my workloads on the cloud that's best suited for that. Pretty tough to do these days, but people are still trying. And a lot of times they do this because of risk management. They don't want to be dependent on a single vendor, those kind of things. Completely understand. Personally, I think that's the hardest part, because how do you pick a cloud for your workload? You have to be an expert in a lot of things and go beyond the marketing, I would say, because every cloud is obviously perfect at everything, and it's hard to distinguish what's what. The other piece is, once you do that, how do you manage all of that stuff? Which is obviously not easy, because there's no standard for management across clouds. And we have Azure Resource Management, AWS has CloudFormation, Google has whatever they are calling it. It's the same kind of idea, but it's vastly different. AWS calls it VPCs, we call it VNets. Similar ideas, but vastly different. And so you really have to think through, if you do that, how do you manage all that stuff? The second trend I'm seeing, and I think that has more promise, is effectively building what I call cloud agnostic applications, where applications can run in any environment. And I think multi-cloud is being hyped right now. I think it's much more important to think about hybrid compute. Because if I'm a retailer, I will have shops that might need local compute. If I'm a manufacturing person, I have some factory where I do need local compute for safety, security, latency, whatever reasons. And I still want to use cloud capabilities. I still want to use functions or events or whatever it is. And today, it's really hard to do. And so one of the things we're investing in is making our Azure capabilities, especially the ones that are important for software development, including AI, available on Kubernetes. So you effectively can run it on a Kubernetes cluster of your choice, and you can use Azure Functions, Logic Apps, Event Grid, those kind of very advanced cloud capabilities, and run them on a Kubernetes cluster wherever you want. And we believe that that's important. And also I believe that the applications of the future will actually have local parts and cloud backend parts. They work together. It's either or, it's going to be both. And I think that's going to be important. And then the last piece of the puzzle, that we call it our ARC strategy, is managing all this mess. So from virtual machines to Kubernetes clusters, from databases on Kubernetes clusters, applications on these things, you have to figure out how to manage them. And so what we have decided to do is extend the Azure resource management framework to on-premises resources or non-Azure resources. And the way we do that, I really love the way the team did that, is they effectively make the design decision to say, instead of coming up with a new management paradigm for, let's say, Kubernetes clusters running on VMware or on GKE or something, they effectively turn those resources into Azure resources. So from an Azure management perspective, the thing looks like an AKS cluster. It is a GKE cluster, but from a management perspective, it looks like it was an AKS cluster. So everything you can do with the Azure portal, the command line interface, Azure policy, and all this other stuff, you can effectively apply onto the GKE cluster or onto an OpenShift cluster running on a VMware. And that is very, very elegant, because everything we do in Azure to extend our management capability, including third parties, will work on those resources. And again, other people have taken a different approach where they're building a new management stack up that is multi-cloud. Again, it's a fair design model. I personally think it's going to be challenging because you don't have to attract everybody again to build management applications, extend it, do the backup, whatever. And again, we chose to anchor it in Azure and effectively say, hey, everything that Azure can do for management, we now can do for Kubernetes clusters, virtual machines on other platforms. Again, I think a pretty elegant approach.
Yes, indeed. I work a lot with AKS. I must say that. So I have another question, but it's a hard one. As a German, what do you think about the Israeli beer?
Drinking a German beer in Israel, which is nice. So I have actually not drank an Israeli beer. No, actually, that's not true. Yesterday, did I? Alejandro, did I drink an Israeli beer yesterday? That was not an Israeli beer, right? I was about to say I drank one yesterday.
You drank some Israeli arak.
Yes, and homemade Israeli wine, which was fantastic. So I have not drank Israeli beer this trip. Generally speaking, I would say it's okay. It's not necessarily your forte. I think technology is more the thing, but it's drinkable.
Okay, none taken. So everything is all right. Lost.
Cheers. I hope everybody has a drink. Yeah,
Fine. All right. So 3 years ago, Microsoft acquired GitHub. What's next for open source on Azure?
Well, so GitHub is obviously the center of open source universe, at least for a lot of people. We acquired GitHub, there were 28 million people on it. When I think last time I checked, we are now almost at 50 million people working with GitHub. So that's pretty cool. We have announced a new product called Github Ae, which effectively is a private cloud managed service that we're running for a customer. So there are three flavors of GitHub now. So you have the public GitHub, which people use to collaborate across the globe, across companies. Then we have the enterprise product on premises. And now we have this new product called Github Ae, which effectively is a clone of the big GitHub, but running on behalf of a single company. So we did that primarily for the JEDI contract in the US, where we said they wanted their own inner source management team and said, hey, we would love GitHub. So we effectively said, yep, that's a great idea. We ported it into Azure, brought it on Azure, and now we're going to offer that as a general capability. But with all of the GitHub functions from actions and stuff like that. So love that. So that's the GitHub side of the house. Azure itself is doing a whole bunch of stuff. I just saw a LinkedIn edit where we talked, where we just released our Java SDK in beta or preview. So that's Java, I think 11. And by the end of the year, we will have the Microsoft Open Java SDK for 17, or Java 17, out there as well. As soon as that becomes real, we will ship a version. So we are investing in Java as an open source capability, Linux, obviously. We've done a lot of work with what's now called Tanzu unit, used to be Pivotal, with Spring Cloud. So I would say that open source is not only alive and well at Microsoft, it's becoming even more important and ever more important as part of our ecosystem. Again, don't forget that .NET is also fully open source. So it's not semi-open source as some of the other stuff is, like Java is still not really open source. There's still some Oracle patents pending kind of thing. Whereas .NET has been fully open source and is not property of Microsoft anymore. A lot of people, for some reason, don't know that or choose not to know that, but it is a fully open source environment. So from my perspective, lots of stuff going on, super excited about the Linux work we're doing, the Java work, and also the .NET work we're doing.
All right. Many companies in Israel work a lot on data. They suggest many data solutions. There is a lot of buzz around it. And overall, there is a discussion that they may have been lacking some data governance. Azure is offering such a solution, or will offer such a solution. What do you think about it? Or what kind of solution is that?
Wow, so let's talk first. Data governance is going to be one of those things where I would say the market is going to go crazy soon. Because most customers realize, like, yeah, we have data warehouses, we have databases, we have files, we have data lakes, we have God knows what. What is in those things? Who has access on those things? And especially when you see the EU coming out with new guidelines for Schrems 2 and other guidelines, which are pretty tough to implement. And all of a sudden the customers are like, holy, what do I do? And how do I effectively implement all of this stuff? So we decided some years ago that data governance is going to be super critical. And we built a product called Azure Purview. And Purview is composed out of two big pieces, and there's a third one coming. The first one is a technology we built in-house called the data map. And the data map we built for our GDPR efforts. So when GDPR came out, we said, oh, how do we comply with that? And so, typical fashion, we put a team together that built effectively a scanner. The scanner goes into database, into files, into SAP systems and whatnot, and grabs the metadata of what's available and puts that into a catalog. And so that data map is built, I think, on top of Elasticsearch or something like that. And we extended it and customized it and so forth. And so data map is a key component of Azure Purview. Again, a scanner that effectively allows you to bring in data. We're building a ton of connectors to AWS capabilities, GCP data, Oracle, business applications, and we're also building SDKs for people that want to build custom connectors. So if you have a custom app that you want to surface the data into a catalog, we can accommodate you. The second part, we had internally built our own catalog, but the team that started to productize it said, you know what, I think we should go and utilize Apache Atlas. And so Apache Atlas is actually our catalog metadata system. And then we built two things. One, we made Apache Atlas Azure friendly and multi-tenanted and so forth, because by design it's not. So we had to do some work. And then we're building applications on top, which are primarily today around the data governance people to say, okay, I want to set up understanding who has access to these things, who are the people, what data do I have, and also the business user. So one of the things that catalogs are great at is you can add a ontology. I think they're calling it a business dictionary, and you can then effectively tag data with meaning. Because a lot of times you will see a column that has C000789, which maybe Fred, who built the thing, knows what that means, but nobody else, like, what is C099, whatever? And so you can effectively tag data and says, this is an order number, or this is actually a customer name, or something like that. Again, that's something that we're building there, and that's what we are shipping soon, or have shipped already. So it's available in preview for sure, but I think we're GAing it very soon. The map and the catalog, and the experience on top. And then the third piece we're working on right now is policy. Because the next thing you want to do is saying, now I understand what data I have, now I understand where it is, now I want to say every credit card data needs to be either obfuscated or better encrypted. So now you want to say that and then enforce it. And we acquired a company called Blue Talon, and Blue Talon was in this business. They were effectively a policy language, and they had execution agents that would sit in front of the database, take the database command, execute the command, but then do filtering, do obfuscations and other things before it returns the result sets. And so we took the Blue Talon technology, worked, because Microsoft has a couple of policy languages for those kind of things, information protection and those kind of stuff, combined them so that we now have a unified Microsoft data policy language. And then we also took their policy execution agent, and in the databases or environments we control, we're building it natively into the technologies. For example, SQL Server will automatically understand the policy language and enforce it in the database. Postgres and MySQL, MariaSQL, where open source, will do the same thing. Cosmos DB and so forth. Where we have databases that we can't control, let's say Oracle, we will continue to use the agent or proxy approach, where you can deploy the proxy in front of the database and still apply the policy. And so it's going to be pretty interesting. Expect a preview soon, and the goal is to ship it sometime at the end of the year, early next year. But the idea is you can do these statements, like names should always be obfuscated, or things should always be encrypted and stuff like that.
That sounds actually great. So there are many things coming into Azure. Some of them are in preview state. What does it mean actually? And is it possible to use it? I mean, preview is production ready?
Well, there are two phases to previews. So the first one is what we call a private preview. A private preview simply means you have to be invited. Isn't too hard. The only bar is that if you're in a private preview, we expect you to use the technology. We used to have a beta program, if you remember the on-premises days, where we shipped gazillions of disks, and in most cases nobody used them because they didn't have time or whatever. And so for private previews, we're pretty strict, because what we want to do is get feedback. And we want to make sure that people use the product, help us understand what works and what doesn't work. Catalog is a great example. We have been in preview for a while with the product, and we effectively learned from a lot of our private preview customers that there were edges in the product that just didn't work. And so we iterate on this product and release a new capability so that we are asking our clients to try and test. So that's private preview. There is no money involved, it's really about the tech. Then we do public preview. And public preview is the last finishing, where we say, okay, now we know that the product in general works, let's make sure that it works for more use cases than what we have seen so far. And it's often also the trial point for the business model, saying, okay, we're going to charge this. Is that going to work? Or are there people going to cry and whatever they're going to do when prices are deemed too high? I know Israel cries a lot. I got that. But it's one of those where it's that really finishing the product, making sure it works for broader use cases, and also making sure that the business model works. And then we GA. Private preview, you do not go into production. If you are building a business plan and a project plan on a private preview feature, you shall never get another private preview feature, because we might delay the product by a year, by 2 years. If it's not right, we are not going to ship it, right? Public preview, it depends. If the feature is, from our side, pretty ready, and we feel that you are quote unquote a responsible customer that knows what they're doing, we will step up in select cases together with you to figure out, okay, we can go into production. So I have put customers into production on public preview, but only with the explicit support from the engineering team. So you can't just go and do production and then say, oh, it didn't work, stuff like that. You have to get the engineering team to say, yes, absolutely, we can do this. And it's very rare.
Okay. AI is becoming a base for many applications right now. And does Azure have any enhancements or add-ons to support AI development or AI environments?
God, what a question. Yes, of course we do. And there are two layers of AI today. So one is what I would call mainstream AI. And it starts at the infrastructure level, where we have optimized AI environments based upon GPUs, FPGAs, so specific hardware that helps you run the AI faster, train the AI faster and cheaper, which is the other point that's important. FPGAs are field programmable gateways, so they're effectively a piece of silicon that you can program. And we have developed a language compiler that allows you to take a AI model and compile it down into what the FPGAs speak, which is a language called syslog. And so that's effectively one way, and they are very, very good at inferencing. So if you have inferencing scenarios, the FPGA is awesome. And we ship that FPGA in Azure, but we also ship it in Azure Stack Edge. So if you want to run inference scenarios at the edge, like videos and so forth, FPGAs are a fine idea. So hardware. The second layer is frameworks. And there we primarily focus on open source frameworks, PyTorch, TensorFlow, and those kind of things. And then on top of that, we have pre-built APIs. They're the so-called cognitive services. And the cognitive services deal with vision, transcription, translation, language services, decision services. So there are APIs that you can use, and you can extend the models. For example, most of what we just talked about, most people will not understand because it's not normal English that we're using here. And it's certainly important that you can extend the vocabulary of normal English with domain-specific capabilities. And you can do that for language, for images, for other implements as well. The goal is that you don't have to build your own model. You might have to, and we go down one level to the framework level, but effectively we try not to. And then last but not least, we have bot technology and other capabilities that allow you to build these scenarios like cognitive agents and stuff like that. And supported by technologies like Azure Machine Learning, which effectively helps you with automatic training distribution and stuff like that, and MLOps, which is a critical capability, analog to DevOps, where you have code. MLOps is for model management. So it deals with registering model, versioning models, deploying models, and all this other stuff. So that's what I call traditional AI. Sounds really funny because most people are still grappling with what is AI, but that's traditional AI. What that means is most of the time you're building very small models that are targeted at one specific thing. For example, a language model will only understand language. It won't understand images. You have an image model for that, and so forth. And the way you build applications is you pipeline them together in a sequence. For example, we have an application called Cognitive Search, which uses our search engine And you start with, let's say, AI-empowered OCR and end up with entity extraction. But those are n different models you're running in a pipeline. Traditional AI. Now there's modern AI, which is effectively large-scale models. And it started off with OpenAI, Google, Microsoft, and a bunch of other folks effectively working on how do I increase the variables I feed into that model. And now we are at brain level variables that we can feed into an AI model. GPT-3 is the last generation of that stuff. And what those models effectively do, you can, the traditional thing or the thing that people do is feed Wikipedia into those models. And now you can say, I would like a 1,500 word essay about the beginnings of the state of Israel, and the thing will write it for you. Of course, it will only use the Wikipedia database, and so if there's any nonsense in there, it will bravely repeat it, because it can't distinguish between nonsense and what's else. So it started off with language, and we use the GPT-3 models and predecessors in Bing, in Word, in Exchange, and so forth already. And now the next version, so GPT-3 is actually that version. It actually not only understands language, it knows is being also used for image detection. So now you see large-scale models, and we think they will be multimodal. So you can effectively do many things with that model. And there was a really great tweet by Andrew Ng, so NG, who is one of the Google brain guys. And he said, at the end of the day, what is going to happen is that you have AI models, and the data is going to be shaped to meet the AI models instead of the other way around. Because today you have data and then you build AI models against it. Now you have GPT-3, and you will feed the data that fits GPT-3 because the AI model is so super powerful. And that is ready for production, but not yet mainstream. So again, traditional AI, actually I would say ML, a lot of things on machine learning. Then you have AI capabilities, traditional, small models. And then now you have emerging these large-scale models that can do multimodal things.
Thank you for sharing from your knowledge and experience. Do you have anything else to say to this stage?
Thank you for being here. I really appreciate it. First of all, seeing faces without masks is awesome. Seeing friendly Israeli faces is great. And so really appreciate you coming and spending your evening with us. Hope you enjoyed the beer and the conversation. Super happy to be here and spend more time with you. So if you want me back, happy to come back. So thank you very much.
So we're not